Hello everyone. Today we're going to look at integrating things that are called partial fractions. We use partial fractions when we're integrating a rational polynomial that we cannot integrate in other ways. So first we would see, is it a u substitution? Is it a log? Is it an inverse trig? Right? Remember, inverse trig is things of the form a number over 1 plus something squared. What this is going to do is it's going to undo the addition or subtraction of fractions to make the integration easier. We're only going to look at certain types of rational polynomials. Again, assuming that we can't do it another way, what we're going to have is the denominator being a product of non-repeating linear terms. So remember, a linear term is something like a plus bx. Okay, and they're not going to be repeated, so we're not going to have something like 2 plus 4x squared or 3 minus 8x cubed. So non-repeating linear terms. So here's an example. We have 1 minus x over 1 plus 2x times 2 minus 3x. So each of these are linear, and they're not repeated. It's not the same linear term. Our goal is to rewrite this fraction into the sum of two fractions. Each of our fractions is going to have the denominator that's part of the product. So we're going to have something like a over 1 plus 2x plus b over 2 minus 3x. Most of this is going to be solving for a and b, which are going to be numbers. So we start by writing out the equation. We have our original rational polynomial, and it equals our sum of our two new terms. Again, a over the first denominator's factor plus b over the second factor. Then what we do is we multiply both sides by the denominator on the left. So what we're going to do is we're going to clear out the fractions, something that you did in an earlier math class. So if I do that, if I multiply the left side by the denominator of the left side, it cancels and I'm left with just the numerator. And then if I multiply this term by my denominator, the 1 plus 2x's cancel and I'm left with a times 2 minus 3x. And then when I multiply my second term by my denominator, my 2 minus 3x cancel, and I'm left with b times 1 plus 2x. You can kind of think of it like cross-multiplying. I'm taking a times the other denominator plus b times its other denominator. So this equation is true for all x, and in particular, it's true for the values of x that make the original denominator 0. So what we do is we take each of our denominators and solve it for 0. So we have 1 plus 2x equals 0. We solve for x. We get x equals negative 1/2. I take 2 minus 3x, set it equal to 0, solve for x, and I get x is 2/3. So I'm taking each factor in my original denominator, set it equal to 0, and solve for x. These I'm going to plug into our equation that we now have here. So if I plug in x is negative 1/2, then on the left-hand side, I have 1 minus 1/2, which is 3/2. And then plugging in negative 1/2 into my right-hand side, this guy is 0. That's how I got negative 1/2. So I only have this term left. And when I plug in x is negative 1/2, I get 7/2 a. So my new equation is 3 over 2 equals 7 over 2a, which tells me that a is 3/7. Okay. And now we're going to do it again for our second value of x. If x is 2/3, then my left-hand side is 1/3. And on my right-hand side, 2/3 makes this guy 0. And I'm left with 1 plus 2x, where x is 2/3, times b. So I end up with 7/3 b. And again, I solve for b, and I get that b is 1 over 7. Now you can always go back and check it out. if I plug in 3 over 7 for A, plug in 1 over 7 for B, if I do out the right-hand side, I cross multiply. Make sure you do get your left-hand side. Okay, you can always, always, always check this. There's absolutely no reason not to. So now this is what we get as our fraction. It looks a little messy because I have a fraction inside of a fraction, but that's fine. The point is that this new sum of two fractions is much easier to integrate. So if I make this now an integration problem, I have taken out my coefficients. My 3/7 has come out. My 1/7 has come out. So my numerator now inside the integral is just a 1. To integrate this, it's just a really nice u substitution, and then it's a natural log problem. So for my first one, u is 1 plus 2x. So du is 2 dx. And I'm going to have a 1 over u, so I'll have a natural log. And in my second one, I'll use a different color, u is 2 minus 3x. So du is negative 3 dx. So again, I'm going to have a natural log problem. I'll end up with 1 over u. The part that I see most people make a mistake on is they don't actually do the u substitution, so they're missing their coefficients. They're not having this 2 that they need. They're not having this negative 3. So when you do this, don't forget you still need to do a really quick u substitution. So you're going to have a new coefficient out front. So we have the 3/7. We have that 1/2 that I just mentioned. Again, we have the 1/7 and then the negative 1/3 from, again, the fact that my dx is negative 3 dx. Okay, so don't forget those coefficients. Again, it's a really quick u substitution, but you have to pay attention. And then we'll clean it up, and this is our answer. And again, just with any integration problem, you can always differentiate it and make sure you get back what you started with. Okay, so that's something to keep in mind. So let's try another one. And again, most of this is finding A and B. The integration itself is really, really easy. It's a nice u substitution, and then it's a natural log problem. So here's another one. Let's integrate 5x minus 2 over 4 minus x times x plus 2. So the first thing I'm going to do is I'm going to set up my partial fractions. I'm going to have a over my first factor plus b over my second factor. And then I'm going to multiply both sides by the denominator on the left. And again, that's equivalent to just cross multiplying over here. So I have a times x plus 2 plus b times 4 minus x. The next step is to set my two denominators equal to 0 and solve for x. So the first one, I'm going to take 4 minus x, set it equal to 0, and I get x is 4. So if x is 4, this guy cancels out, and I'm left with a times 4 plus 2, which is 6i, and then 20 minus 2, which is 18. Okay. Then I solve for a, and I get that a is 3. Next, I take my other denominator, set it equal to 0, and solve, and I get negative 2. And of course I wrote the wrong number down. That should be a negative 2, not a negative 4. So negative 2 minus 2 is negative 12. Again, negative 2 cancels this guy out, and I'm left with 4 plus 2, 6b. So this is correct, but I wrote down the wrong number over there. So that is with x being negative 2. Solve it for b. Again, that's negative 2. And b is also negative 2. Again, you can always double check it. Plug in your a and b up to here. Do out the math. Again, the cross multiplication, make sure you get what you started off with. So now I am going to plug in. I plugged in my a and b. I also pulled them out because, again, they're coefficients. I'm allowed to do that. So I have 3 times the integral of 1 over 4 minus x dx minus 2 times the integral of 1 over x plus 2 dx. Okay, so again, a and b are here, and I've just pulled them out. Again, what I'm left with is a really, really nice u substitution and then natural log problem. So I end up with a negative 3 because I have a negative x down here, so du would be negative dx. So negative 3 ln of absolute value of 4 minus x minus 2 ln of absolute value of x plus 2. So if u is x plus 2, du is dx, and there's no extra coefficient out front for that guy. Okay. So let's try another one. Notice here our denominator is not factored. It won't always be factored for you. So in particular, for these ones where it's not already factored, you want to ask yourself, can I do this a different way? Does it have to be partial fractions? So the first thing you want to do is see, is the numerator a multiple of the derivative of the denominator? Right? Is this a u substitution problem? But if I differentiate x cubed, I get x squared, and there's no x squared in the numerator. So it's not a u substitution type problem. Okay, so if that's the case, then I want to see, can I factor it? And this one's fairly easy to factor. There are only 2 terms. So the first thing I want to do is look for a GCF, and that's x. And if I factor it out, I have x times x squared minus 1. X squared minus 1, again, it's 2 terms. So is there a GCF? No, we just took it out. The next thing you want to look at for 2 terms is it a difference of 2 squares? X squared and 1 are both squareds. It is a difference, it's subtraction, so I can factor it using the difference of 2 squares. So I didn't realize I had it all written out. So I have x times x plus 1 times x minus 1. So you got to remember how to factor. Okay, none of them will be terribly difficult. But you do have to remember how to factor. So now, notice we have 3 factors. So I have a over x plus b over x plus 1 plus c over x minus 1. So I've got a, b, and c in this case. Again, I'm going to multiply by the denominator. So now with 3 terms, it's not just cross-multiplying. But what we do is we take a and we multiply it by every other denominator besides a's. So I have a times x plus 1 times x minus 1. For b, I have b times x minus 1. For c, I have c times x plus 1 times x. So I multiply it by every denominator except for itself, because when I multiply by this guy, in particular for c, these ones cancel, and I'm left with the other ones. Okay, so you're always going to be multiplying by every denominator that's not the numbers itself's denominator. So in this case, we have 2 other denominators. But otherwise, it's still going to be the same thing. We're going to look at each of the factors, set it equal to 0, solve it for x, and that's the value we're going to plug in. So for the first one, I look at x, and I get 0. So 0 on the left-hand side gives me negative 2. Now notice that if x is 0, this is 0, and this is 0. And all I'm left with is my first term. So I have a times negative 1 times positive 1 is negative a. So if negative 2 equals negative a, then a equals 2. And then we do it for the next one. So if x plus 1 equals 0, then x is negative 1. If I plug it into the left-hand side, I get negative 6. Again, if x is negative 1, this is 0, and I'm just left with my b's. And I have b times negative 1 times negative 2, which is positive 2b. And that gives me that b is negative 3. And then for my last one, I said x minus 1 equals 0. I get x is 1. I plug it in. This cancels out, and I'm just left with my c's. So on the left-hand side, I have 2. On the right-hand side, I have 2c. So if you do this correctly, whichever denominator you're setting equal to 0, the other letters will cancel out, and the letter above it is the one you're solving for. So when x is 0, I solved for a. When x was negative 1, I solved for b. Now that x is 1, I'm solving for c. And I get that c is 1. So again, here I have plugged in my a, b, and c, and I have also taken it out of the integral for a and b. C was a 1, so I don't really have to do it for that one. So I've pulled out the a, which was a 2. I pulled out the b, which was a -3. And again, all of these are really, really nice use substitution natural log problems. And if I notice that the coefficient of x for all of these is a 1, which means du will be dx, and there's no having to play around with extra coefficients. So when I integrate it, I just have 2 times the natural log of, don't forget the absolute values, so the absolute value of x, minus 3 times the natural log of the absolute value of x plus 1, plus the natural log of the absolute value of x minus 1. And also don't forget your constants. Okay. So let's try another one. So here the denominator is factored for you, and again we have 3 factors this time. So I'm going to set it up. We're going to have a over x minus 1, b over x plus 2, c over x minus 3. Now notice it's all multiplication in the first part and then addition in the second part, so the order doesn't matter. I could have a over x plus 2. I could have a over x minus 3. It doesn't matter as long as you're making sure to plug it back into the correct spot once you've solved for them. So I'm going to multiply everything by the denominator. Again, I'm going to have a times the other denominators plus b times the other denominators plus c times the other denominators. And then I take each one, each denominator, each factor, set it equal to 0, and solve. So my first one is going to be x minus 1 equals 0, so x is 1. On the left-hand side, I get -1. And again, my b's and my c's cancel, and I'm just left with the a. And I get -1 equals -6a, solve for a, and I get positive 1/6. Then I do it again for x plus 2. Set that equal to 0. I get x is -2. This cancels out. This cancels out. I'm left with just the b. I have 14 on the left-hand side. I have 15b on the right-hand side. Okay. Then I solve for b. I get 14 over 15. Sometimes your answers aren't pretty. Sometimes they're fractions. Sometimes they are nice integers. The nice thing about it is that it will be linear, so it's at most a fraction. Okay. And then lastly, we'll do the c's. X minus 3 is 0. That means x is 3. The a's cancel, the b's cancel. So if I plug it into x squared minus 4x plus 2, I plug in 3 over here. I get -1 equals 10c. And c is -1 over 10. So again, I'm going to rewrite it by plugging in my a, b, and c, and then I'm going to take them outside of the integrals. So I have 1/6 times the integral of 1 over x dx plus 14 over 15 times the integral of 1 over x plus 2 dx minus 1 over 10 times the integral of 1 over x minus 3 dx. Again, when I do my u substitution, my coefficients of x are all 1. So my du will be dx, and again, there isn't an extra coefficient that I have to worry about. So I just get the natural log of absolute value of x minus 1 over 6 plus 14 natural log of absolute value of x plus 2 over 15 minus the natural log of the absolute value of x minus 3 over 10. So I'm just rewriting it. It doesn't matter if you put the fractional coefficient out front or if you put it all into one fraction, right? So there's a couple ways you can always write them. Okay, so I want you guys to practice some of these. Let me know if you have any questions. Again, most of it is algebra. It's finding a, b, and c. And the integration is just a really easy use substitution and then natural log. Okay, so let me know if you have any questions. Thanks.